Okay, looks to me like I'm dropping some frames here. I'm gonna stop the stream for a second or pause it or whatever the heck it is and make an adjustment in the bit rate and see what happens. Arg. That's better. At least nothing's really changing on the screen. We'll see what happens when we get to the opening video, but it looks a little better. Well, so I guess we're about ready here. I didn't actually, uh, 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 I didn't actually manage to complete a single run through. I try to, but then I keep finding things I want to change, and that blows the timing. And then I can't do it too many times because then uh, it it loses its spark. So we'll see how it goes. Uh, um, but looks like we got a couple of folks here. Thanks for coming by. I don't really have this whole, I see these live streams where they do the comments are on the screen and stuff like that. I don't really have that set up. Uh, uh, but while we're the few, the proud, the elite at the moment, then whatever. Uh, uh, the feed coming back at me on this preview looks really terrible. I'm hoping that's just me. We'll see. I got an opening video that's gonna, I think, really eat the bandwidth, so I'm worried about that. We shall see how it goes. Anyway, thanks for coming. I do appreciate that. The number one feature of YouTube is that you can skip around. You can skip most of the crap, which is, you can still do it with live streams. You just, go to another window and come back. But I understand. I've never actually tried one of those premiere things where you take a video, but you can only watch it. You can't skip it when the first time it's played, because it sounds like a terrible idea. If you're going to do that, you should do it live. That's the idea. I mean, it seems like folks, mostly are bugging out after the 15 minutes or whatever it is that we try to do our piece. Actually, one of the things that I was thinking about was, like when they have celebrities who are plugging movies and stuff, and they just say, oh, welcome to Topeka, come see the movie, welcome to whatever, like that. I think I keep thinking I ought to try to do some like TikToks or something like that, and just really super short little things like stories about the self-image, something like that. But and so one possibility, what I was thinking, was, I could do them in the live stream. After we record the 15 minutes, the update. If I was a little more prepared, could do a little 5-second spot for the update, and then try to do some takes on a TikTok video, some sluggy little punchy thing. I don't know, whatever it would be. With the whole point being that we could then cut it later, and it would be sitting in the live stream, so it would be there, but it would be intended for repackaging, just like the 15-minute, we'll see today, video is going to do. So, well, we'll see how it goes. Okay, I better get my act together here. Let's go back to the waiting room. See you in a couple minutes. I guess I'll back it up. I'll back it up, and we'll just open it again, because why not? See, that's so stupid. Uh, uh, um, uh, uh, oh man. Uh, uh, I'm gonna do a fresh start, so we're gonna run a little bit long here. Uh, uh, oh dear. Okay. We'll start at 12:02. Hey folks, it's 2024, and this is the second take because I just screwed up the opening by forgetting to unmute the microphone. It's on the checklist, and I missed it again anyway. I was talking about 2024 being the year of democratic society if we can keep it. And I'm worried about that, and I want to talk about that in the year going forward. But right now it's T2sday, and let's make it happen here. Okay. The goals for this time was the single loop interface running and the Breitenberg car running. I did pretty well with the single loop interface. Talk about it. The Breitenberg car is it's funny. The hard part of the Breitenberg car seems to be the wheels. And the second part is the light sensor, but step by step, I'll talk about it, and then we'll go from there. Okay, the serial loop hardware, the serial loop software, that's what I want to talk about, and then the simulator. This is the big picture. The original, first, the T2 matrix stuff that we were doing for the artificial life, digital replicator, all that stuff was completely internal to the T2 matrix. The idea here is to have some kind of connection so that a chunk of matrix no longer necessarily or even intended to be indefinitely scalable. In other words, I mean, the matrix, a finite chunk of the matrix, it's always been finite, of course, is going to connect to something out in the world and have senses and motor actions and so forth. That's the goal. The connection went through a couple of things, and this is just straight engineering task given the T2, in particular given their slowness. This is not meant to be a biological model. This is not meant to be an artificial life model. None of that. This is just straight engineering given how much bandwidth we have and how much time we need, how much time we have and how much bandwidth we need. To this idea of making a loop that here, this laptop is the simulated world, goes through a USB to serial port, and when it wants to send a packet to say this one, it sends it to the first one that has to recognize that it's supposed to forward it, which sends to the second one, which sends it to the third one, which has to recognize it's for it, and it does whatever it is, and then the response comes back around the loop. That's the goal. We had a terrible little prototype, a couple of them that I hand put together. Here's what we have now. So I sent a board off, got some back. So that's it. So here they are. These are the first generation serial tabs. And the idea is instead of, trying to figure out, these are male and female connectors. And so we can just stick them together in the correct direction, assuming I can get the correct. There it is. And then they click together, and the idea is I can just kind of spin them while I'm connecting them, so it'll make kind of a twisted pair. And they disconnect and so forth. So, it's not too bad. And let's, right. And so then the big trick, so these things are all designed so that they fit right into the tile, serial ports on the tile. That's what this thing is for. But we also need to connect to the FTDI cable, the USB thing that goes off to the laptop. And in order to do that, I figured, well, I'll just use a male-to-male connector here, a gender changer, so that I can plug one of these into that thing, and then that'll look like an extra node on the loop, and everything will be fine. And so I hooked that up from a USB cable to the keymaster to another tile, and then back to the FTDI cable. And, so here was a picture of it. There you can see the gender changer over there. And then it comes out and it goes into one of these, and then from one it goes to the other one it goes on back like that. Beautiful. And I hooked it all up, so this part is the part that's close to the world, right? Because that's going off to the USB connection, and these parts here, these tiles here, are like the brainstem. That's where the information from the spine hits the brain, the matrix, the cortex. This is going to be a lot simpler than that. There's going to be like a whole lot more tiles around it, so only certain tiles will be connected to the spine, and the rest of the matrix that's involved will have to figure out how to route stuff to and from that. So that's the picture. And we'll see how it's coming. The first attempt that I did, it didn't work. And why didn't it work? Because when you use a gender changer, you're actually changing something important, which is each of these cables has to take the transmit signal and turn it over, and so that it plugs into the receive signal of the downstream thing, and then its transmit, or its TX goes into RX of the next one. And when you put in a gender changer, you don't do that. It ends up being TX going to TX, RX going to RX. It doesn't work. So I took one of them, and so the black wires are ground, the red wires are the data. I cut them. I soldered them, I heat shrunk them, and that's what this actually is here. You can see there's the heat shrink. I also use Sharpies to color in the board just to make it clear that this is a crossover cable. And then it worked. So that was pretty cool. I wanted to show you, I've got it running right here. I wanted to show you the demo, but my overhead camera is currently screwing up. I've got to deal with that. So I just took that picture instead, but we can look at it here. So in the top window, that's the talking directly to the workstation that we're at. The one in the middle is talking to the Keymaster by SSH. The one at the bottom is talking to the other. We can start T2sday loop runner. And this is all just debug stuff. It's, so they're just sending little messages to test what's going on. We can start the next guy, and he's doing the same thing. Now, when we start the world, the one that's doing the simulation, that's kind of in charge of everything. That's the host in this case. Again, because this is not meant to be indefinitely scalable. This is just meant to get the job done. So we'll start this up, and it will sort of take over and start doing things. And that's the key right there. Loop length is 2. So it enumerated the loop by sending a special packet around that get each of the loop the tiles that forwards it decrements a counter, and then come back and you can tell from how many times it was decremented how big the loop is. And and again, this is all just silly debug stuff, but one thing that is quite interesting is the last 2 characters of each of these packets, cube, OMM, KJF, all that stuff, those in fact are a checksum, 2 bytes that summarize the rest of the packet, and they have to be consistent. Based on a discussion on the Discord with Tim Tiggs, who was saying, if you're going to feed this data through all of these tiles, how do you know it won't get corrupted? And I said, well, I'll put in a checksum. I wasn't really thinking that it was going to be a problem, but it turns out it really is. Why? Not actually because of like cosmic rays, although that could certainly happen. But what does happen for sure is, a tile in the loop might reboot or might be rebooted or whatever. And as it turns out, the serial port on the T2 tiles, when the Linux kernel is booting, it gets used for debug messages. and there's really, nothing that you can do to control that without getting extremely low level. And if you do get low level, then you lose information that you may well need. But the messages that the kernel they have a 1 in 65,000 chance of getting the right checksum, so they don't, and they all get rejected by the downstream guy. He just tosses them all out, and then whenever the loop doesn't work while the thing is in the middle, but once it comes back up and the T2 sur loop starts running, then it just picks right up again. So that was pretty nice. Okay, so that's that. And that's the serial loop software. So at first it didn't work because we had to have the crossover cable. But was actually true in the demo that we just looked at, I didn't take the time to show it to you exactly. The packets run backwards. You really can't see it, but one of them is labeled. One side of the thing is labeled loop out, meaning the data is supposed to come out there. The other side is labeled loop in, and the data is going the other way. It's like, I can't believe how I can screw up these things so reliably. Sergey has put in a pull request because I managed to screw up the inverse symmetries in the MFMS simulator, and I haven't dealt with it because I haven't gotten back to Ulam yet, but I will once we get this stuff set up and it's time to actually start running the signals through the matrix. I'll have to go fix that, Terrible. Okay. So what did I do about the fact that signals were all running backward? I did another order to Oshpark, the printed circuit board manufacturer. I didn't use rush service on them, so they haven't come back yet. They might actually ship today. We'll see what happens. So that's the story on the hardware and the software for the spine in effect. Now, on the simulator, the goal was to use this thing, Mujoko. I don't remember. Joint coordinates or something, motion, whatever it is. It was the newer, more advanced thing, and I completely failed. And it's just sort of a reflection on what programming seems to be these days, that the reason I failed is because there was a package called Mujoko_Pi, a Python package that was previously used a lot. It had a lot of documentation. It had a lot of tutorials, easy to get going. But now the authors, the creators of Mujoko came out with their own package, which is much lower level, and there's very little friendly documentation for it. And I tried to figure out how to do things in the new Mujoko way. And I couldn't. I even tried one of the large language model AI things and said stuff like, how do you, connect to the display in Mujoko without using Mujoko Pi as part of the prompt. And it would give me a bad answer, or it would say, okay, here's how to do it without using Mujoko Pi. Step 1, import Mujoko Pi. That kind of thing. Anyway, I finally gave up. And so I looked around and I found, this rludobots on Reddit, subreddit, for doing little robots, little 3D robots in a world. And I started working through it, and it's wonderful, tiny little steps. And I didn't even realize at first that it was created by Josh Bongard, who's an artificial life guy. He's a buddy. And this thing is great. So I just went through it, installation, and here's an example of how finely down he takes it to it. He reminds us in each step to start a new branch so that we don't lose our old stuff and go check it out. Very, very detailed, very nice. Simulation, 1 link, 2 links, joints, sensors, motors. I did it all the way up to the refactoring step that he's got to clean it up. It's great. Now I'm branching off because I'm not going to use neurons and senses like he's doing, since the point is to connect to the T2 matrix. But it got me this far, and so that's the new plan, to use PyBullet. So here's a little bit of what that's looking like so far. This is one of the evolutionary robots. The simple beginning is 3 cubes that are connected together by joints. And I started looking for wheels, you know, instead of just cubes. I wanted cylinders. I found wheels. I mean, there's basically this whole examples directory that I hadn't looked at that has like a ton of stuff in it, including a really complicated little car that I spent a lot of time trying to get it to drive. Like on the upper right here, this thing is like the wheels are spinning 360 degrees. That's pretty tricky. But that's where we're at now. And there's no sensors yet, and there's, you know, these things are way more complicated than the Breitenberg vehicles are supposed to be. Now, I'm not 100% sure it has to be Breitenberg vehicles, but we'll see. So overall, we're supposed to do deploy the interface, hello T2 matrix. I'm saying enumerating a loop is hello T2 matrix. So we did okay. Next goal is to actually come up with a Breitenberg vehicle, Breitenberg car controlled by the T2 matrix command. That's it. That's the next goal. And you know, have lots of fun. And so that's it. And I've run a little bit long, but Happy New Year, and thanks so much for stopping in whenever you came to take a look. Okay, well, so that's it. I'm gonna stop the recording here, and see how we did. All these folks, Matt Smith, hey. Yeah, because I screwed up. Kempe, I don't know how do you say that? Kempe de Jong, and TXRX CRCs, yeah. Well, I mean, again, this is not an infinite, this is not even an indefinitely scalable hardware idea. This is, you know, take a patch of indefinitely scalable hardware to use it as a model, an implementation of a nervous system, that kind of thing. And so again, that's why I tried to stress that it's the spine is not meant to be an indefinitely scalable spine and all of this stuff, because any actual instance. Yeah, I guessed, Mr. Jiang, that you were undefined on Discord. I'm not sure how I exactly made that connection, but I believe I knew that. And you know, thanks so much for contributing and way back. I mean, you've been checking in on this stuff since before the T2 Tile project, right? I mean, all the way back in just the like Demon Horde Sword and that era. Anyway, and Matt Smith is a UNM buddy, like that. Yeah, Matt Smith, have a friend with Kurt, so I went with a wired interface, a couple of things. The underlying systems, the BeagleBone greens that are inside the T2 tiles don't have wireless, so it would have to be added somehow. And, you know, wireless feels great until you start getting collisions, until you actually have, you know, 76 transmitters in the space of, you know, 4 foot round, whatever it happens to be. So I've been burned trying to use wireless and having, very unreliable stuff, lots of packet loss, lots of very variable latency. So if I didn't need to do that, then I'd rather not do that. So that avoiding wireless is a just having been burned. Uh, um, and we'll see. Again, when I started working the numbers for how much packets we were going to need to send and receive from each tile in order to, given the fact that the T2 tiles are so slow anyway, and we're going to be doing this very heavy time lapse, that we could have, a party line and say, okay, now here's your sensor data. Please give me your motor data. Okay, now here's your sensor data. Give me your motor data, and so forth, and have plenty of time to do it without having to stress it. So, my original fantasy was to have talk to every single one serial port directly with 76 cables coming together in one place. This is a good deal simpler, so we'll see. Hopefully that answers. That makes a certain amount of sense. Folks that have actually done, robots where you have to do wireless for the nature of the rule, the swarm robot soccer or whatever it is, or stuff like that. If they're not actually autonomous, uh, um, deal with have all of these horror stories about wireless stuff. So anyway, yeah, right. Back when I was still teaching, so that was 2018. Uh, uh, been doing this a long time. I would also like 2024, in addition to saving democracy, I would also like to see if we can manage to get some traction on these ideas, the robust first, the best effort, the indefinite scalability, uh, uh, in penetrating into some wider communities. There's little signs of it now, and that makes me excitable. Open MPI, meaning the parallel uh, message passing libraries. I'm not sure. You mean, could I use OpenMPI on the T2 tiles? Is that the question? If it is, in principle, I could, but I would have to implement. There's no TCP level, there's no IP level already implemented in the connectivity of the T2 matrix. So in order to run MPI, which assumes that there is arbitrary point-to-point connections are possible, at least as far as I know, last I looked, uh, um, that it would be a problem. I would have to implement an IP layer, in essence, on the tiles, only to use it just for the nearest neighbors, like that. So I'm not sure that that's a good impedance match, MPI, for what we're trying to do here, especially because typical uses of MPI have barriers. They're trying to be deterministic. They farm out a whole bunch of tasks and then reduce and wait until the last guy shows up before passing the barrier and going on to the next iteration. And again, we want to learn how to do without that. We want to learn how to find out when they're not synced at the level of the entire computation. So we'll see. And thanks so much for the questions. Undefined. Oh yeah, and so you were talking in the Discord about FPGAs and implementing a whole bunch of cores on an FPGA, and I would love to do that, or I would love to be able to support someone else to do it, 24 hours in the day. But it's important to understand that the movable feast machine is a pretty inherently sequential transition function. So that even if you try to do hardware accelerators, which I want to do, like tagging, bit tagging, and type matching and stuff on the event window, I think that stuff could all be sped up and made essentially order one rather than order number of sites that you visit, which is the way it is now. But even if you did that, even if you had parallel hardware for the event window operations, there's still a whole lot more of sequential processing the way these things are implemented. So it would still be the case that 1K is not enough RAM for, you just need more for a stack for the remaining serial nesting stuff. And again, one could look further. One could say, well, the stuff that was implemented in Ulam by recursive calls or mutually recursive calls or whatever the heck it is, could be re-implemented in some flatter way and then cast to hardware. But that's big. That's really big project. And so I'm not ready to go down that road. And part of why we've been able to do, pretty cool cellular automata, the sort of Ginger Rogers of cellular automata. They do everything that the von Neumann machine does, but backwards in high heels, because the whole thing moves while it's doing it. That's because of the power of being able to program sequential transitions instead of just a table lookup or some extremely simple sort of thing like that. So 1 megabyte SRAM. I've looked more at the Grayskull chip, and they have I did reach out to them and they haven't answered, and I don't think they will. They're looking for 640 kilobytes per core. Yes, that would be good enough. I mean, what we need room for a stack, we need room for scratch, and we need room for the entire physics has to go somewhere. And so the idea that we could put the physics in PRAM in Flash, something like that, that would be great. But when in like looking at the Grayskull chips, they don't have per core Flash as far as I could tell. So that 1 megabyte of SRAM has to also hold all the code in addition to the stack and so on and so forth. So if we didn't have to, if the code could be elsewhere, still on chip, I mean, it can't come in from the outside because too much bandwidth. You got to have a copy of the entire code base, all of the elements in each core, because they're going to be running different elements at the same time. And again, maybe you could figure out ways to route the instructions from the outside, but ouch, I don't want to do that either. But 640K bytes, well, now if you're saying 640K bits, well, who knows? I mean, if somebody was going to give me and say like one of these Grayskull things or something and say, you've got 1 meg SRAM, and mostly it's got all of this machine learning stuff, fuse, multiply, add, all of the stuff for doing what I consider traditional neural networks now, how quickly the world changes. That goes out the window. Well, we don't use any of that in the movable feast machine. We just use the scratch processors. It's got 5 RISC-V processors in addition to all of the tensor crap on each core of these Grayskull things, plus 1 meg. So as far as I was concerned, I would just take a couple of those ARM RISC-V cores and the 1 megabyte SRAM and pretend all of the neural net tensor stuff wasn't there. And I could see that the tens torrent might not all be that interested in having me as a poster child customer, especially given I was only going to buy a couple of them instead of buying thousands for my data center. Many try to do without solving the problem of determined hardware, of deterministic hardware. Is that what you mean? And you know, parallel systems, traditional parallel systems, which are, again, still deterministic, once you actually manage to get rid of the race conditions, assuming you do, is it's important, it's great, it's interesting, and so on and so forth. It's just not what this is about. Anyway, well, this is great. Thank you so much for showing up, folks, and asking questions. I mean, I love to respond. You know? And I'm giving up officially. I'm giving up on rushing off to start the render to get the cut down official T2sday update out as quick as possible. If folks are willing to actually take time out of their day to show up live, I will stay here until folks have their questions answered, or I fall over dead, because I'm usually I've been working straight through for 20 hours or whatever, just trying to get the update together to go live, and then I screw up with the mute button again. Anyway, okay. Any other thoughts from folks, or shall we call it for today? And I will get the render started and go have lunch. Yeah, Happy New Year to you too, Kempe. And yeah, I am going to keep on saying, goal is have fun. I feel like, I kind of miss that sometimes. And it's worth remembering. It's worth praying for. It's worth rehearsing. Don't forget to have fun. Okay. Yeah. Thanks, Matthew. And Matt, you're mad. I remember you're mad. And I am gonna pull the plug on the stream, I guess. So that'll be it. Okay, folks, hopefully see you in February, or see you in the Discord. I will try to answer things in the Discord better. It's just, where do I find the time? And talking is better because it's quicker. Okay, that's it.